Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we have topic of 3.8, that is called the linear momentum. Okay, it is defined as the quantity of motion in a body is called linear momentum. The quantity of motion in a body is called linear momentum. Okay, or we can define it the product of mass and velocity is called linear momentum. Okay, it is a simple product, not the dot or cross product. Okay, mathematically we can write as p is equal to mv, where p representing linear momentum, m representing mass, v representing linear velocity. So look at the first definition, the quantity of motion. The quantity of motion means velocity. Quantity of motion means speed. In a body mean mass. When there is a quantity of motion in a body, that is called the momentum. So momentum is equal to the product of mass and velocity. So it depends on mass and velocity. So if the mass is greater, momentum will be greater, and if the velocity is greater, velocity is maximum, the momentum will be maximum. So momentum depends upon mass and velocity equally. Means if the mass is double, momentum will be double. If the velocity is double, momentum will be double. So it means momentum depends on both equally. Okay. For example, if we talk about the truck, we know that the mass of the truck is very larger. If the mass is larger, it means its momentum is larger. Now talk about the bullet. We know that the velocity of bullet is very high, very fast. So it is very high velocity. So it means its momentum will be maximum. For example, we talk about the bullet train. We know that the mass of the bullet train is larger because it is a train. So its mass is very larger. Its velocity is very larger, means high. So its mean its momentum is very maximum, because mass and velocity both are greater. So its momentum will be very maximum. Okay. Now talk about the unit. Remember, momentum is a derived quantity, and the unit of derived quantity can be obtained from the equation. So look at here, the unit of mass is kilogram, the unit of velocity is meter per second. So the unit of momentum is kilogram meter per second. Okay, now talk about the nature. Remember, momentum is a vector quantity. Momentum is a vector quantity. It means momentum will have a specific direction. Momentum is a vector, so momentum should have a specific direction. So what is this direction? So look, p is equal to mv. The direction of momentum is depending upon direction of velocity. Means the direction of velocity will represent the direction of momentum. Okay, so why it is called linear momentum? It is called the linear momentum because it depends on linear velocity. If the linear velocity increases, momentum will be increased. If the linear velocity decreases, momentum will be decreased. Okay, so the direction of linear velocity will be actually the direction of linear momentum. Suppose a mass m1 moving with velocity v1, a mass m2 moving with velocity v2, both have the same direction, so their momentum will also have the same direction, so both the momentum will be added. If they are opposite, the momentum will be get subtracted, because vector has a direction and the momentum has a direction which is in the direction of linear velocity. Okay, now this is the introduction of linear momentum. Now we are going to develop a relation between the momentum and force. Okay, now if we want to discuss the relation between momentum and force, this is called the relation between Newton's second law and momentum. The relation between Newton's second law and momentum. Okay, now we are developing a relation. So according to Newton's second law, we derived an equation that is F is equal to ma, and we know that the definition of acceleration is rate of change of velocity. So rate of change of velocity is called acceleration, and we know that change in velocity means final velocity minus initial velocity. Okay, so change in velocity is actually equal to final velocity minus initial velocity. Okay, multiply m in inside, so it will be mvf minus mvi. Okay, so I multiplied m inside, so that is mvf minus mvi. Okay, mvf is the final momentum, mvi is the initial momentum. Okay, so it is equal to delta p, final minus initial is equal to delta. So that is the another definition of force. So force can also be defined as the rate of change of momentum is called the force. The rate of change of momentum is called the force. So force is that agent which always bring change in the momentum. Means if you apply the force, the velocity will be increased, momentum increased. If you apply the force, the velocity can be decreased, momentum will be decreased. So force is the agent which always bring change in a momentum. Okay, now talk about the impulse. Talk about the impulse and change in momentum. Okay, what is meant by impulse? Impulse means the change in momentum. So remember, every impulse is a change in momentum, but every change in momentum is not impulse. How? Let's study it. So first, I want to define impulse. What is meant by impulse? When a force is applied on a body in a very short interval of time, that is called impulse. So impulse, what is meant by impulse? Impulse means jerk. When you apply the jerk, that is called impulse. So the literal meaning of jerk is impulse is jerk. Okay, look at here, the definition of force is rate of change of momentum. Okay, so we can write as delta p is equal to f delta t. Okay, so the formula for the change in momentum is equal to f delta t. This is the formula for the change in momentum. Now, so delta p can be represented by j. What is j? J is actually the impulse. J is actually the impulse. Limit delta t tends to 0 into f delta t. Okay, so I write delta p is j. So j represents delta p. J means change in momentum. J means impulse. Limit delta t tends to 0, f delta t. Limit means restrictions. Limit means conditions. So we apply the restriction. We apply the condition that the time interval should be very small. The time delta t should be very small. The delta t tends to 0, approaches to 0. What does it mean? It means that whenever we apply the force in a shorter interval of time, that is called impulse. So impulse means when you apply the force in a shorter interval of time, because here delta t means approaches to 0, delta t approaches to 0, delta t near to 0. So if you apply the force in a shorter interval of time, that change in momentum is called impulse. So impulse means the change in momentum. Okay, remember, every impulse is change in momentum, but every change in momentum is not impulse. Why? Because if we apply the force in a larger interval of time, that is only change in momentum. But if you apply the force in a shorter interval of time, that change in momentum is impulse. So every change in momentum is not impulse. Okay, an impulse is a vector quantity. Okay, the direction of impulse is represented from the direction of force. The unit of impulse is, look at, the unit of force is Newton and the unit of time is second, so the unit of impulse is Newton second. Okay, this is the unit. Now suppose, let us consider the definition of impulse. Suppose the bowler throws the ball towards the batsman, the ball comes and the batsman hit the ball with a bat. When the batsman hit the ball with a bat, so the ball and the bat comes in contact with a very short interval of time. So it means the batsman apply the force, a larger force, but the time of contact of a ball with the bat is very small. So that time of contact is very small. So it means the bat applying the force in a shorter time, so the ball will feel a very large impulse. So impulse means a force applied at a very short interval of time. Let us consider another example. Suppose a person jumps from roof and he falls on the floor. When the person comes and fall on the roof on the floor, then the person will stop on the floor. When it stopped, its momentum is changed and momentum is become zero. It means the momentum is changed in a very short interval of time, so the person will feel a very high jerk. So it means that is called the impulse. So it means that impulse is actually the change in momentum. Suppose the person is jumping from certain height into the pool of water. Suppose this is the pool of water. So when the person falls in the water, so the person will get slower and slower, but gradually. So it means the momentum is changed, but it takes a larger time. So that is not an impulse. That is only the change in momentum. So it means that when the momentum is changed in a larger interval of time, that is called only the change in momentum. But when the momentum is changed in a shorter interval of time, that is called the impulse. Okay, look at the graph. The graph between the force and the time interval. So if I draw the graph here, so this is called T1, this is called T2. This is the time when the two bodies comes in contact. This is the time when the two bodies leave their contact, mean they are out of contact. So if the time interval between them is larger, that is not an impulse. So this area is not an impulse. This area is only the change in momentum. But if I show this graph, so look at here, this is the time T1 and this is the time T2. This time interval is very short. So this area of this graph representing the impulse, because the time interval is very short. So if the time interval is very short, so that area of FT graph representing the impulse. Okay, that is all about the impulse. If you have any query, any questions, so you can ask in comment section. So take care. Allah Hafiz.